Hello students, today's agenda is to check your homework. We're going to learn about quadratic linear systems, and your assignment for today is 10.15. Today students will be able to find the points where a quadratic and a linear equation intersect. And what does that mean? So if we graph a parabola and then we have a linear equation, we're going to find those 2 points. And today we're going to do it algebraically only, so you don't have to worry about, oh, I don't know how to graph the parabolas. We haven't gotten there yet. But it's just so you know that this is what we're looking for. Those 2 points where they intersect, the line and the quadratic equation. Sometimes you're going to have 2 solutions. Sometimes you're going to have, one solution where they meet only once, and sometimes you will have no solution. So one solution or no solution. So it means that if you have 2 different points, you will have 2 solutions. If you have 1 point, 1 solution, and when they don't meet, that's no solution. It means they don't intersect at any point. So just to recall from quarter 2, we did system of equations, but it was only system of linear equations, and I don't know if you remember, but we used to have one solution. So one solution, so meaning you would give me 1 point. No solution, that means that my 2 lines didn't intersect. Or infinite solution, meaning that one line was graphed like that and then the other one would overlap, and so that will be infinite solution. And it's something similar, except that now instead of having 2 lines, it's going to be a parabola and a line. Okay, that's the only difference. Okay, so let's begin with our first example. And remember, today we're just going to learn how to find those solutions algebraically, meaning we're just going to use algebra to figure them out. And so the first example says y is equals to x squared plus 5x plus 9, and y equals negative 2x plus 3. And in quarter 2 we learned different methods, which was elimination, substitution, and graphing. But for this one, I'm just going to tell you that this is equals to this whole thing. It's like having a $20 bill and then having maybe a 10 and 2 5s, or different amounts, right? But it's equals to a $20 bill. This $20 bill is other set of different types of bills, but this is equal to the same. So it's like taking away in my first one the $20 bill and inputting the different types of dollar bills, but to make it 20. Okay, maybe you don't remember that relationship, but again, y is equal to this and y is equals to this. So if I take y away and replace it with this amount, it has the same value. Okay, so it's like not doing anything to this side. So I'm going to put negative 2x plus 3 is equals to x squared plus 5x plus 9. And you can always have this first and this second. That's okay. It will be the same thing. I'm going to cancel this part, so I'm going to be adding 2x and also subtracting 3 from both sides. adding 2x, and notice how I align it with the x to make it easier, and subtracting 3. And that way in here, by adding, I cancel this, and by subtracting, I cancel this, and that's going to be equals to 0. Now on the other side, I have x squared plus 7x plus 6. And I'm going to be solving this either with the GCF, with the by factoring perfect squares, by factoring with the diamond, or completing the square, or the quadratic equation. Whichever method you find easiest, that's okay. So for me, it seems that the diamond is easier because you have the 6 and you have the 7. And what two numbers multiply equals 6 but added equals 7? Well, it's 1 and 6. I open my parentheses and I'm going to put x plus 1, x plus 6. And that's equals to 0. Now this means that I'm going to be multiplying these two factors. And to make the product 0, one of these two factors has to be 0. And how can I make this 0? Well, x is going to have to be -1 or -6. Okay? So these are my values for x. Now I have to find the value of y to know where is it. And having two different answers, that means that I'm going to have two different points. So I have two solutions. Meaning that I'm going to have two solutions. And I don't know how they're going to look, but I'll show you. Oops. So two solutions. I'll show you in a minute. See if I can catch one of the programs on the internet. So -1, how can I figure out my y? Just like when we did with system of equations, you choose to find the second value, you choose one of the two equations, and the linear equation is going to be easier than the quadratic because you have to do less steps. And so you're going to have to do the same process twice, one for the -1 and one for the -6. So it's going to be y equals -2 times x. X is going to be -1 plus 3. And so that's -2 times -1 is +2 plus 3 equals 5. So that's my first value, my y value for the first point. And then I'm going to do now for the second one. So it's -2 from the equation times x, which is -6, plus 3. And so that's 12 plus 3 equals 15. Okay, so these are the 2 points, my two solutions where my parabola and my linear equation meet. Okay, two solutions, -1, 5 and -6, 15. So let me show you this. And to give credit, I'm going to say that what I'm using is desmos.com. So if you want, you can actually go ahead and use it on the internet. Desmos.com, whoops. I'm just going to go click here and put y equals x squared plus 5x plus 9. And that's the parabola that it creates. Then you go down to the second section and you put y equals -2x plus 3, and that's the other graph that you create. Now you click on it, and if you notice in here you go -1, +5. That's your first point right there. Let me take this out of the way. -1, +5. And the other one should be meeting at -6, 15. Again, you don't have to do this. It's just for you to see how they really do come to that. And I don't know if I can make this smaller. So you have, can you see the -6 right there? Maybe you can't see it. -6, and then you go up, 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 and this is +15. It's right between the 14 and the 15, if you can see in there. Whoops, sorry about that. Okay, so -6, +15. Okay, again, you don't have to know really how that works right now, but it's so that you can see the connection. Okay, so let's do another example. If after you look at the whole lesson you feel like you need to go back to it, that's fine. But again, let's just review really fast the steps. First thing you need to do is make this equals to